Hi friends, I am Probal Chakraborty. I want to discuss fluid mechanics, the very important chapter elastic solid stress strain analysis problem. Friends, before when you want to learn advanced fluid mechanics, you have to learn continuum mechanics. This questions is from continuum mechanics. So at first I read these questions. The displacement in an elastic solid is given by u1 is equal to ax1 plus 2x2 plus 2x3 x3 x1 plus 2x2 plus x3 u2 is equal to a into minus 2x1 plus x2 u3 is equal to a x1 plus 4x2 plus 2x3. Here a is a small quantity. Find dilatations. Dilatation is very important. Dilatation rotation vector, sphere and principal strain corresponding principal axis. So friends, this problem is very interesting problem. That's why I discuss. Okay, what is the stress? Everyone know that strain component we know. Okay, strain component. Before this answer is strain component. Strain component is Eij. We know this formula. What is the Eij? Eij is very simple. Half into del ui divided by del x, capital X j, plus del uj divided by del xi. Good book of this fluid mechanics, you can get AEH lab. Elasticity, plasticity book. Elasticity book, a theory of elasticity books. So friends, strain component is Eij equals to half into del ui divided by del xj and del uj divided by del xi. So friends, whatever I get E11, when I want to find out E11, then whatever I get del ui means this is the tensor representations ui and xj. It can be possible del u1 divided by del x1. Why del u1 divided by del x1 is equal to a? Why it is? Because friends, when we get E11, that means it is half into del u1 divided by del x1 and plus del u1 divided by del x1. So if you add this, so it is half into 2 into del u1 divided by del x1. 2 cut, we are getting del u1 divided by del x1. Very simple. That's why this value is a, because if you derivative as u1 is equal to x1 plus 2x2 plus x3, so del u1 divided by del x1 is equal to a divided by del x1 divided by del x1 and other portions is 0 and it is coming a. And u2, whatever you get u2 is a into minus 2x1 plus x2. So del u2 divided by del x2 is equal to del u2 divided by del x2 equals to also same a in case of, because it is same case, and e33, this is whatever I get e22 is equal to a, and e33 everything is based on strain tensor. This is the strain tensor formula. This formula is strain tensor formula. So E33 is equal to del U3 divided by del X3 is equal to A. So friends, this is the notice that I get E11, E22, E33, and after that whatever I have to get E12 and E21 due to symmetry. This tensor is also symmetry. So E22 is equal to half into del U1 divided by del X1, del X2 plus del U2 divided by del X1. This is the formula. So friends, whatever I get del U1 divided by del X2, del U1 divided by del X2 is equal to half into 2, and del U2 divided by del X1 is equal to minus 2. So I get it's 0. And another way is E23 is equal to E32. This is also symmetry, and this portion is equal to half into del U2 divided by del X3 plus del U3 divided by del X2. So whatever I get, friends, simple, del U2 divided by del X3, del U2 divided by del X3 is nothing, so it is 0. And del U3 divided by del X2, its value is 2, so you get this value is del U3 divided by del X2 is equal to 4a, so you get 4a. So whatever I get 2a. I get 2a. And E31 is equal to E13. This is the symmetric. Half into del U1 divided by del X3 plus del U3 divided by del X1 is equal to half into 3a plus a is equal to 2a. E31 means in here X3, when it is whenever we did the derivative U1 divided by X3, U1 divided by X3 we get a, and U3 divided by X3 we get whatever we get 3a. U1 divided by X3, sorry, my questions is wrong, it is 3x3. Problem is based on 3x3, ax1 plus 2x2 plus 3x3. Okay, and U2 is equal to a minus 2x1 plus x2, and U3 at first I write this questions also. U1 equation must a into x1 plus 2x2 plus 3x3, and U2 is equal to a into minus 2x1 plus x2, and U3 is equal to a into x1 plus 4x2 plus 2x3. This is the main fact, friends, that when you ever u3 divide by u1 divide by del x1, this is the 3a, and u3 divide by del x1 is equal to a. So whatever I get 2a. Now stress tensor can be represented. I can represent it as a matrix. Tensor is it is the representations of the matrix, because as it is a tensor calculus, so I can it has a matrix representation. So my matrix representation is this way: 2 2 2 2. This is my matrix representations. My matrix representations, friends. E3 everything is 1. Now E33 is also 2a. Sorry, my E33 is also 2a. So my matrix representations is Eij is equal to a 1 0 2 0 1 2 2 1 2 2 2 2. And now whatever we have to do, dilatations is very simple. Dilatation rotation and vector. Dilatation rotation vector theta is equal to E11 plus E22 plus E33. E11 plus E22 plus E33 is equal to A plus 2A is equal to 4A. Dilatation. This is my dilatation, not rotation vectors. I have to find out rotation vector. Dilatations is E11 plus E22 E33, means trace of Eij. Trace of Eij is my dilatations. Now again they ask rotation vector. What is the rotation vector? Rotation vector R is equal to half into rot U is equal to half into I j k, and U del x del y and del x3, and sorry, it is x1 x2 and x3, and it is u1 u2 and u3. This is the rot u. Rot u is this, and whatever you get it half into I into del u3 divided by del x2 minus del u2 divided by del x3 plus j, simple multiplication, del u3 divided by and plus j is equal to whatever I get del x3 into u1, del x3 into u1 minus del u3 divided by del x1, del u3 divided by del x1 plus k is equal to simple little determinant value, friends. Simple u2 del u2 divided by del x1 plus minus del u1 divided by del x2. This is my total rotation vectors. Whatever I get rotation vectors, and these vectors del u3 divided by del x2, del u2 divided by del x3, whatever I get 2ai plus aj minus 2ak you get everything from the differentiations. When you will differentiate, then you will get u1 divided by del x1, u2 divided by del x2, u3 divided by, if you derivative these equations, you get these equations. After that, they ask shear. Whatever they ask, they ask sphere and principal strain and corresponding principal axis. So shear is from Eij above. We see that about x1 axis, about x-axis by an angle 2e23 is equal to 4a, and about x2 axis by an angle 2e23 is equal to 2e31 equals to 4a. So principal strain are the roots of the equation. Principal strain are the roots of the equation mod of a minus e 0 0 a minus e 2a 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 and 2a minus e is equal to 0. So friends, this determinant value, whatever you get determinant e cube minus 4a square minus 3a square e plus 6a cube is equal to 0. So e minus a and e square minus 3ae minus 6a square is equal to 0. So whatever I get e1 is equal to a, e2 is equal to Sridharacharya formula 3a plus minus root over b square means 9a square, b square minus 4ac means 24a square divided by 2. So whatever I get 3a plus 1 is plus 9a square plus 24a square means root over 33a divided by 2, and this is the e2 and e3 is equal to a into 3 minus root 33 divided by 2, and ni, let ni be the direction ratio, ni be the direction ratios of the principal axis of the principal principal axis corresponding the strain E1 is equal to A. This is the strain, corresponding the strain U1 is equal to A, and then we have the following equation. We have the following equation. What is the equation, friends? Our equation is A minus E1 and N1, 1 plus 2A N3, 1 equals to 0, and A minus E1 N2, 1 plus 2A N3, 1 equals to 0. And next is whatever I get, next equation is 2A. I get two equations. Principal of the axis 1, this is the number 1, and this is number also, this is the same, this is the number 2, and next I get 2A N1 1 plus 2A N2 1 plus 2A minus E N3 1 equals to 0. How I get, friends, this from this? Here is it is according to this determinant A minus E, you will multiply the direction N1 1, and here N3 1. Here you get N2 1. This vector, this is the vector is row vector. According to the row vector wise, I get this three equation. This is a principal direction ratios, and now whatever I get the equation, the principal axis. This is the equation of principal axis, and therefore the direction cosine of the principal axis, axes are 1, 1 and 8 divided by root over 33 3 minus 1 and 1, 1 minus 8 divided by root over 33 plus 1. Thank you. Another okay, this is the one direction, and another direction is simple. Another direction is another is 1, minus 1, 0. How do I get? I get this from these three equation. I get their direction ratios. Thank you for watching.